We are here at StopTech's manufacturing facility in sunny Southern California. We're going to take a tour and show you that there's a lot more technology that goes into building a high-performance brake kit than meets the eye. We're here in the friction lab with Greg Wu, who's the general manager at StopTech, and Greg's going to explain to us why we start with pad formulation.
Dave, in every big brake kit that we're designing from a clean screen, we have the opportunity to choose the brake pad size and formulation that we think is going to work best in the application. So when we're designing a system, and that starts with caliper and rotor sizing, we're designing around the pad. So pad formulation, what goes into the pad, what do we expect that output or that friction coefficient, that mu will be, is where we spend a lot of our energy in research and development up front.
Okay. So that starts at this table or with these elements back here?
So you pointed them out. We've got all these powdered materials or sintered materials, the base elements that make up a pad. And that can be what we call different categories like binders, resins, friction fibers, friction modifiers, and we buy them in their raw state like this. And our director of friction R&D, who's got a PhD in friction science,
wow,
has the responsibility of mixing them into what we call a compound, which then gets placed into a mold.
Yeah.
And we take that backing plate, that friction material that he's mixed together, we put the cover of the mold down in there, and next it moves into a process by which we press and cure the formulation to actually make a finished brake pad.
So this is what your finished prototype looks like then, is that right?
Yes. By the time
you've actually put like a squeal indicator on there?
So that would be, like a retention clip, for example, to hold it in the caliper.
Oh, is that what that is? Okay.
Yeah, so later on we've got to think about how are we going to test the thing. It's actually got to fit in a production caliper in order for us to test it on the dynos. So yes, any of the additional features that are needed to make that caliper function, with the brake pad correctly, and that could be, something like a retention clip, the chamfer on the side of the pads, the slot in the center, all those features have to be done during this prototyping stage.
So now that Greg's given us a quick education on the formulation side, this is Sean Gaffney, their lead test engineer. He's going to tell us a little bit about how we go from that process onto the big dynos.
Yes, exactly.
So this spider graph is an important thing, I'm told. What's going on here?
Right, so the spider chart is something that we've developed in-house to sort of understand how these pads are performing. We run them through a gamut of tests, and at the end of the day we've got so much data that we need to really present a clear picture to the end consumer on what is actually going on. So as we look at the spider graph here, you can go around the outside and this would be theoretically your perfect performing pad.
Right.
It's a pad you can't buy, nobody makes it, it's impossible to find.
It's the best of everything.
Exactly, right. So if we're looking at something like stopping power here, you'll notice that pads right here, pads A and C, have about the same stopping power.
Right.
Pad, however, B is a little bit less.
Right.
So if we're talking about a performance application, you're going to want to see some data that's very close to this point here.
Okay.
That's going to give you the most stopping power.
Right.
Things like rotor life, dust abatement, just how dusty are those brakes going to be on your car? Nobody really likes dust.
Mm-hmm.
But down here, noise abatement, that's our biggest, most important aspect. If a pad is noisy, nobody's going to want to buy it.
Right.
So that's actually one of the first tests we'll run. We run an industry standard SAE J2521 test.
Okay.
We test everything that we get through a noise test first.
Okay.
Because again, if it's noisy, nobody's going to buy it.
Right.
Yeah.
So when you do those tests on the small dyno and you like what you're seeing on here, is that when you make the move out to the big dynos?
Right. So we'll use the chase machine to sort of pre-screen the good materials that we're getting, and we can sort of target those materials to certain applications.
Okay.
So it's not necessarily we see something on the chase that we don't like, we just never test it.
Right.
It may have an application, use in something else that we're maybe not considering at the time. So
put that data away in the vault.
Exactly. Yeah. We'll still save it. We'll still have it. Be able to refer to it later if we need to. Exactly. Okay. Yeah. So the materials that we really like that are excellent performers, those go to the front of our dyno queue and we get them tested immediately.
Cool.
Yeah.
Let's go check that out. So in these big blue cells behind us is where they do their noise testing, which is obviously a very important part of the process. And on this open dyno here, you do other kinds, it looks like temperature testing you're doing here?
That's correct. So we call this essentially a friction dyno. So what we test on this on this dyno is anything from friction, calipers, rotors. We can test the whole corner group. So what you're seeing here, while it may not be a BBK, which we definitely can test, this is just an OE replacement corner. So we can run different types of friction and see how those are going to perform on the specific platform. You'll notice some thermocouple wires. One of these is going to each of the brake pads, so we know what temperature the brake pads are going to run at during the test.
And the cycle is meant to simulate different kinds of driving conditions.
Exactly. So in a drive cycle test, we'll have there'll be a highway section, maybe a country road section, things like that, that would simulate what an end user would actually do.
Could you simulate a lap around a racetrack?
Sure, we definitely can. In fact, we have some vehicle data recorded from anywhere from Laguna Seca, Road Atlanta, on some specialized cars that we've had.
So you can take that data, plug it into this computer, and it'll run that lap.
Exactly.
Very cool.
Yeah.
We are here at the 5-axis mill station, where Greg's going to explain to us how we go from the raw forging to these mass optimized versions. Is that right?
Absolutely. So when we talk about a brake system and a brake caliper specifically, that caliper and the rotor is hanging off the side of the suspension, the very far outboard side. We call that outboard side is what we call unsprung mass. So whenever possible, we're looking for weight savings in the brake system. And one of the opportunities to do that is in the caliper machining. So as we start machining, we're usually starting with the forging, with some landmark machining already done. And as in the design phase, we talked about selecting a brake pad size. Next, we're putting it inside of a caliper. We're essentially capturing that pad inside 2 halves of a caliper like this. So the caliper only needs to be as wide in the center as the pad and the rotor. That's a combination of all 3 of those dimensions. And any excess material that's not needed for strength, our engineers can identify by using finite element analysis, or FEA, and design a mass optimized version of the caliper that takes something that started off in size like this and takes out all the extra material that wasn't necessary for strength for that particular application or piston sizing. And now we've lightened the calipers. You can see we put pockets, we've taken off as forged surfaces and netted it out to just the area that's still needed for strength in the caliper.
We've moved over to the piston bore area. Greg, can you explain to us the importance of drilling those bores and how that influences brake performance?
Sure. So in the design phase, when we're talking about getting the right brake bias between the front and the rear of the car, and getting the right force output, not overpowering the wheel and tire, get an interface with the ground, but at the same time not relying on a proportioning valve to move that brake bias back and forth from the front to the rear of the car. The StopTech philosophy is balanced brakes, which means choosing the exact piston size combination, or combinations plural, when there's multiple pistons in a caliper, to achieve that force output that's right for the vehicle under hard threshold braking. So the bores look like this when they're fully machined. And this is one of our street trophy calipers. So what you're seeing here is a leading and a trailing bore. They're different size. We call that differential bore. And they've been cut to the correct diameter, and there's a groove in there that holds the piston seal. And then an upper register groove here is where the dust seal will be pressed down into to protect the bore, the piston, and the piston seal from contamination.
So you're engineering your bore sizes specifically for each application so that you don't need a proportioning valve on the car. You can install it and you know you've got the right brake balance.
That's right.
So once that machining is complete, where does the process go from here?
After that, we're going to go into what we call outside processing, which is how we apply our finishes on the caliper. It'll be anodizing and paint, which are done off-site, and then a quality check of the part for its visual surfaces to make sure that they're not damaged, dented, dinged, and that we don't have any paint flaws like fisheye, dirt, hair even dropping on there. If it's an anodized caliper, we want to make sure it doesn't have any staining on it either.
We're over here in final assembly, is that what this would be called?
Caliper assembly, that's right.
Caliper assembly, and you want to run us through the process here?
Sure. So all of the component parts are already manufactured either in-house or by some of our outside suppliers, and we've already quality checked all those components prior to getting them here in the assembly station. So in assembly is where we marry up those component parts to those 2 machine caliper halves that we saw earlier, create this finished caliper. So the finished caliper already has its pistons, its pressure seals,
Yep.
and its dust boot pressed into each bore.
Yep.
We have our abutment plates, which are there to keep the pad from wearing into the aluminum, so essentially wear strips for the pad as
Yep.
the pad is torqued, towards the direction of rotation as they're applied.
Yep.
Yep. And then we have our other hardware, like our crossover tube that carries fluid between the two halves, our bleed screws, and our caliper bolts that hold the two halves together and also add strength to the caliper,
Yep.
our removable bridge, and our pad pins. And when we talked about those brake pads earlier, in that brake pad selection,
Yes.
how we design a caliper around the pad and the pad selection,
Yes.
there's this concept that says there is no perfect pad for all types of driving. When you're commuting every day and rarely getting on the brakes, your braking needs are completely different than when you're on the track
Sure.
and you're pushing your brakes hard. So one of the design features that's unique about the StopTech caliper family is the removable bridge. The idea here is that with the removal of just two quick socketed chapstick bolts,
Yep.
you can pop this center bridge out in this pad pin, pull your pads out from the top with the caliper still installed,
Nice.
and then drop in your track pads for the weekend,
Okay.
and go out to the track, run those high temperature, high maximum operating temperature, high mu or friction coefficient pads.
Yes.
Maybe a little noisy,
Yeah.
but they give you great stopping ability on the track.
Yep.
When you're all done, do the same process backwards, pop the bridge out, put your street bed back in, drive home nice and quiet.
Yeah.
Great first stop, cold in the morning, no noise, right?
The wife won't even know you were at the track.
Absolutely. So that's part of every StopTech, performance caliper that you see for our street big brake kits, is that removable bridge.
And you were saying earlier too that the two-piece design with this hardware actually adds stiffness compared to a monoblock design?
Absolutely. So when we think about monoblock designs, right, just the fact that it's a monoblock doesn't inherently make it stiffer. So in a two-piece design here, where we're achieving strength by clamping as much of these two surfaces, these two halves together,
Yeah.
and giving the caliper resistance to yawing open
Yes.
as fluid pressure is applied against those pistons,
Yes.
and those pistons and the brake pad press against the brake caliper.
Wants to pry it open.
That's right. These
Yeah.
steel fasteners here have a higher strength than aluminum.
Yes.
So when you're running 4 or even 6 steel fasteners through the center of a caliper, you're giving it both the clamping force and also a yaw resistance or a bend resistance. You've created something that's extremely strong relative to a monoblock of the same mass and the same shape.
And you were saying too that the bridge acts as a strengthening component too by adding mass down the center line?
Absolutely. So this center line, which is our spot where the brake caliper naturally wants to yaw or pivot open, by adding those 2 additional fasteners there that go all the way through and essentially clamping that bridge in the center,
Yeah.
these contact points add strength or yaw resistance
Yeah.
to this caliper, and this bridge, so to speak, becomes its own strengthening rib in the center of the caliper.
Very nice. So this caliper is ready to go on the car?
That's right. And our philosophy here is one caliper is built by one assembly person. So that guy who assembles the caliper, he owns the process from start to finish
Yeah.
to make sure that the caliper he built won't leak once you put it on the vehicle.
Okay. And if it does, you can come back and say you made a boo-boo?
Is
Is there a sticker on there to say it's good to go too?
If it does leak, we want to catch it before it ever leaves the plant.
Okay.
So this caliper is built with a build tag, and
Yep.
it's got a checklist of all the important steps that assembler did while he's putting the caliper together. So our next step is going to be a testing station.
Okay.
Where we'll check to make sure this caliper will retain fluid and doesn't actually have a leak.
Oh, awesome.
Inherent with maybe a flaw in the seal, for example.
So before this goes in the box, you actually test it to see if it leaks?
Absolutely. 100% of the calipers and brake hoses we made, if it's carrying hydraulic fluid, has to be tested before we'll release it.
So for StopTech's two-piece rotors, they start with that raw material. They cut off a nice little frisbee here, and then they start to machine it. This is actually a patented design, is that right?
That's right. So our arrow hats have this air notch pattern on the back side of the hat, the side that interfaces or interacts with the rake rotor. And that leaves a small space between the rotor and the hat that allows air to flow through it and help facilitate cooling of the rotor.
Sure.
So when we think about the rotor being one large cooling fan
Yeah.
and wanting to flow air through the center, this helps that process of cooling when the rotor's spinning as well. So later, in a separate phase of manufacturing, when we machine this to a finished hat, we'll have our bolt hole circle array on there and our offset, which is defined by that front face on the other side,
Yeah.
all ready to go out for anodizing, where it's become a vehicle-specific part, from a wafer to something that is meant to fit directly on that car.
So you can make whatever bore center you want, whatever bolt circle you want.
That's right.
You're good to go. So where does this go from here? Does it go to that next stage where you drill the holes?
So we have one more step in the same series of machines here. That
Okay.
Actually, we call it a second op, where we flip it over,
Yep.
do that front side of the hat, and we do that bolt circle for it.
Okay.
And then next we send it outside for anodizing, and then back for finished assembly.
Amazingly, they go from this raw, is this cast?
This is a casting, so it's a gray iron casting. One giant iron donut.
It is a big donut, and you turn it, you machine it down to this semi-finished product, or is this a fully finished one?
This could be a fully finished ring if you wanted to run the rotor with a plain face and not slot or cross drill it.
Okay.
But typically for most of our applications, we're going to add that cross drilled or that slotted pattern,
Okay.
which is there to help improve that pad to rotor interface.
Okay. So what is the process to go from this to this?
Well, so everything starts in engineering, which is a phase that we talk a lot about.
Yeah.
So we've got a whole series of castings that are in different diameters with different center holes, which
Yeah.
sort of define what we can have as what we call the pad annulus, or the width of the finished rotor.
Okay.
And then we're going to design into that size that's appropriate for that system. Because remember, we've got a brake caliper and a brake pad
Yeah.
that need to clamp on this rotor, and that pad has a specific annulus or height to it as well.
Yeah.
So everything gets sort of thought about as engineered system dimensions all matched together in a final kit.
Okay.
So the process of machining this into a finished rotor is two vertical turning centers,
Yeah.
where we're doing conventional lathe work plus some machining work where we do a fine finish. It's called the straddle cut.
Okay.
That gives us your fine finish with parallelism between the two sides.
Yeah.
Because we don't want any waviness,
Of course, yeah.
like that between
Yeah.
the two sides. So they have to be cut at the same time with what we call the straddle tool.
Okay.
When we're done with those two steps, our next step is conventional 3-axis milling,
Yeah.
where we're putting in this flange pattern that's going to hold our hat,
Yeah.
and drilling our hole array, which is where our fasteners, we call them dry pins,
Yeah.
hold the hat to the rotor. The final step is balance. So when we think about rotors, they're much like wheels. They're not naturally in a state of balance as
Right.
you machine them. So they have to go through a balancing process by which we audit the amount of imbalance that's in the part,
Yeah.
and then do a mill correction where we mill off material off the circumference or the outside edge of the rotor to bring it into balance, then re-audit it or retest it to make sure that we've got a balanced part. We're not going to end up with some vibration once it's mounted on the vehicle.
So now is the time where we make that happy marriage between the hat and the rotor. What is that process like?
Absolutely. So we've done this machining of the hat and the rotor in two different machining cells. And we bolted these two halves together using our fasteners.
Yeah.
But we also have to make sure that we've got what we call parallelism.
Okay.
And the sort of concept behind here is we don't want run out between the two parts. So the mounting face that we've mounted the rotor to has to be absolutely parallel to the face that the brake pad touches.
Okay.
Otherwise, as that rotor sort of moves back and forth, it's going to cause something we call pad knockback. It's going
Right.
to want to kick the pads back to the caliper.
Right.
So we've got to measure total installed runout, or call it the waviness or lack of waviness
Yeah.
in the full assembly.
Okay.
So that's what Nick is going to do right now.
Okay.
He's got the two parts together, and as he rotates it slowly, he's looking at the dimension change from call it a high spot to a low spot on the rotor.
Okay.
Making sure it falls inside of an allowable tolerance limit.
Okay. One last critical component before we go to packaging is brake lines, brake hose.
Yes, we manufacture all the brake hose in-house that goes into our big brake kits. So we start with a spool, complete spool of stainless braided hose.
Yep.
And we press our end fittings on, we crimp those fittings on, and then we pressure check every single hose. So like we talked about in calipers, if that component carries hydraulic fluid through it and is under pressure, we've got to test it prior to putting it into final assembly.
It's Finally, time to make a customer very happy. We are in the kitting area for this complete brake kit. This is a big brake kit for an Audi S4, I believe.
That's right. So the sum of all this individual work you saw going through machining and then inspection and then the component assembly comes together here in the final big brake kitting, where we inspect all of our components one final time, making sure we have the right part numbers to go with that kit, that we have our work instructions or our install instructions that go with the kit to help somebody install it. And off it goes into a box and hopefully to a happy customer.
Yeah.
One of the things to remember though is that every customer who buys a brake kit probably has aftermarket wheels, and there's a lot of different aftermarket wheels out there.
Right.
So before someone goes out and just checks the box to order a kit and then tries to put it on their car, they should always go to our website and download a wheel fit template first.
Okay.
That wheel fit template outlines the profile of the caliper, and it's meant to be printed out in 1:1 scale, cut out, laid up against the back face of the wheel to make sure you have spoke clearance of the caliper, and then once you know you've got that clearance, then you can go ahead and install your kit.
The area otherwise is kind of empty right now, so I guess you're selling these kits too quick. Is that what's happening right now?
Absolutely. The opportunity here is that we have a lot of inventory that exists at our customers' warehouses, like Turn 14, for example,
Right.
and they're helping us handle that fulfillment all the time. So what we're doing here, it comes in waves.
Right.
You know, there's a new popular car, boy, we've got to build a lot of those. And then there's stock out in the network of our warehouse distributors to help fulfill those orders, and we're moving on to other parts of the manufacturing. So different parts of manufacturing are busy in different parts of the day.
Makes sense. To conclude our tour here at StopTech, they've got a layout here of their various caliper sizes, and being the simple man that I am, I'm drawn to the largest caliper, but you're telling me I shouldn't just slap this on my Civic? It might be a little too big?
Might be a little too much for your Civic. So one of the things to remember is that StopTech is an engineered, what we call balanced big brake kit system, where the piston sizing has been carefully chosen to maximize the braking under, call it threshold braking,
Yeah.
the maximum braking before wheel lockup. If we over bias the system by putting too large a piston sizing, for example, in the front axle kit, and under threshold braking, the driver can no longer modulate very well and gets basically gets the wheel to lock up and can't modulate the pedal fast enough, then we've sort of defeated the whole purpose of braking, because
Right.
now the car is skidding, it's not braking.
Right.
So bigger is not always better. You want to choose the piston sizing that best matches the weight, the horsepower, the top speed, the tire contact patch, a number of different factors that are all inherent in that vehicle, and not go overboard lest you end up with no braking and all skidding.
Right. And I guess the smaller is also going to be lighter too, isn't it? And that's a consideration too.
Sure, whenever it's appropriate, we're going to choose the lightest application that gets the correct amount of force output work done. So going overboard is, without getting that braking benefit, is now, as you said, just adding weight to the corner.
Right. That's a good message to close with. Do your homework before you order your big brake kit, and jump on StopTech, give them a call. I bet you they can give you a hand choosing the right kit for your car if you find it a little bit too challenging to do on your own.